Excellent. Well, we'll get started here. So, thank you again, everyone, for joining us. Our speaker today is Dan Rodney, a designer and web developer with over 20 years of experience. At Noble Desktop, he created coursework and leads training initiatives, teaching everything from Figma to the Adobe Suite to Power BI and SQL. He's also been a pioneer in bringing AI into design and business workflows. You can find Dan on X, LinkedIn, Facebook, and danrodney.com. Today's topic is talking to your data, an introduction to SQL. If your data lives in a database, SQL is how you ask it questions. Over the next 60 minutes, Dan will run live queries, show how analysts pull and filter data, explain where SQL fits alongside Excel, Tableau, and Power BI. You'll leave knowing what SQL does and why it's worth learning. So with that, Dan, I will hand it over to you.
All right, thanks and welcome everyone. We're going to be learning about SQL. Of course, some people say SQL. SQL just rolls off the tongue a little bit nicer. Also, do you say data or do you say data? Depends on that's just personal preference. So I say it data and I say it's SQL, but either of them are correct. Tomato, tomato. So, what are we going to learn today? First of all, of course, what is SQL? If you've never experienced SQL, if you've never seen it, today's going to be a great seminar for you to learn about this. So, we'll talk about what it is, what databases are, why do we need databases compared to files like Excel files or things. Why do we use SQL? Why is it so popular? It was created a long time ago and it's still going strong. How do we use SQL across various industries? And we'll compare SQL to things like Power BI and Tableau for doing data visualization. And there will be some slides that I'll be going through, but also part of today is going to be a live demonstration where I'm going to show you how this stuff works. Not just talk about it in theory, but show you how I can connect to a database and how I can write some SQL queries, run them against the database to extract information from that database. So you'll actually see this process. So instead of just hearing about it, you'll actually see this in process. First, we'll go through and talk about things conceptually, and then we'll get to that live demonstration part. And we'll end with ways that you can learn more as Amanda mentioned, this is not a full course. This is an introduction, but this will be useful information so that you hopefully will leave with a clear understanding of what SQL is, how it works, and how you can get started in learning it. So what exactly is SQL? Well, it stands for Structured Query Language. What does that mean? So first of all, it's a language, just like any computer language, where you have things like HTML, which is hypertext markup language. There are things like JavaScript and Python. Now, there are different types of languages. And one thing I must mention that to me, computer languages are easier than foreign languages. I've never been good with foreign languages. Like learning how to speak and write foreign languages have always been a difficult thing for me. But for some reason, I'm good with computer languages. I don't know what it is that's different about them, but you are learning a language, meaning there's certain rules and ways that it works. So, I'm speaking English here. There's certain rules, and English is known for its breaking of the rules. Why is it one mouse and mice? Why isn't it mouses? Hey, look, there's a moose. Look at all the moose. There's no mooses, right? Things like that. But with SQL, it's a structured query language. So the first thing, the structure. So there is a very specific order in which we must write these things, these queries. So query means to question, to query, to retrieve information. So essentially, this SQL language is used to retrieve information from a database or to do things within a database. But the structural part comes that there is a certain specific structure. There's an outline. There is an order to things that we must write this language in a very specific order. Like, for example, in English, we use adjectives before a noun. So it's a red car. Now, other languages sometimes say a car of red, right? But we say it's a red car. So the adjectives come before the noun. So there's a very specific structure for SQL, and that makes it different than other languages, where a lot of other languages don't have that rigid of a structure like SQL does. Now, that rigidity is in some ways a nice thing that once you learn how to write those queries, they always work the same way. So instead of doing things in a variety of different ways, there is just one way you write your query. So once you learn that structure, then you'll know how to write these queries. So we use SQL to query, to question, to retrieve information stored in a database, which is where we have our information. Now, it can retrieve that information, or it can also insert it, it can update it, it can delete things. So the information that we're storing in a database, basically we manage it with SQL. Now, if you are a database administrator, a DBA, then you might use both sides of these things. But if you are more of a data scientist or a data analyst, or you want to look at the information, then you will focus on querying, retrieving that information. And that's what I'm going to focus on here in this webinar today is the retrieving of stuff. You can create your database, you can create your tables, you can create all the stuff using SQL. Those are things for database administrators. So people that are going to be getting into the data structures and how things relate to each other and all of that sort of stuff. That is kind of a different function, but I think there's a lot of people that want to be able to retrieve the information and use the information. And in many ways, we will just be given the ability to look but not touch. We don't want just everybody to be able to go into our database and accidentally delete the table of, let's say, all the users or all of the records for our company or organization or our department. So we don't trust that everybody will be perfect in what they're doing, that if they want to accidentally, if let's say they don't want to, but they just accidentally deleted something, we don't want to even give them permission. So in many cases, you might be given access to a database in a read-only format so that you can read it, you can look at it, but you can't change the stuff. But you can still use SQL if that's all you're given access to. You can still definitely use SQL. We can also use SQL to back up the data. We can export it for use in other applications, whether we're exporting it as CSV files. Those are comma separated values files, which can be opened up in Excel. You can import them into Power BI or Tableau. So we can do lots of things with SQL specific to working with databases. So what is this database? Essentially, it's a collection of tables, and we're going to see examples of these. But a table is kind of like a worksheet in an Excel file. It's where the data is stored. Now, this is not a file-based thing. A database lives on a server. So you have a server that serves up, that allows connections to be made, kind of like you go and you connect into a website where you might have a username and password when you connect into a website, let's say your Amazon account, right? So you log into your Amazon account with your username and password, and then you can see a list of the purchases that you made, and you can purchase new things. So Amazon, there are servers that account lives on, right? And so a database is where that information is stored. And there are different tables or collections of information. So for example, here I have a users table, an orders table, a line items table, and a products table. And these are all connected or related to each other. And so the idea of this particular database, and we can see a list of those tables over here, is that users can, let's say, go into our application or our website or whatever might be the front end of what people see. But on the back end, the stuff that they don't see, the stuff that lives on the server, is we're storing all of that user information, their name, their email, their account password, where they live, when they created their account. So let's say, if you have a credit card, they might say, oh, thank you for being a member since, such and such a year. You've been a member for 10 years. Thank you. Right. And when you call up phone support, they're like, thanks for being a card holder for the past 7 years, because they know when you created your account. And now users can place orders. And so we need to know who placed that order, when the order was made, and where it's going to be shipping to. Now, that place we're shipping to might be different than where that user lives. So the user can have their address, but they might be shipping to a different person or a different place. Right? So who are they shipping to? Where are they shipping to? Doesn't have to be themselves. And then on an order can be made up of multiple items. So line items would be your invoice items. So different products or services. So, which order is this associated with, right? Because you can have a specific order ID, like order number 200 could have 3 different products each with their own price, each with their own quantity, and their status. Has it been delivered? Is it back ordered? Has it been returned, right? You don't necessarily return entire orders, you can return individual line items. And then as far as the product ID refers to product number, let's say 100 or product 1000. And so then we can look up and see, well, what's the name of that product? What's the title of it? What's the normal price? Tags maybe help us to find that particular product. And so, is it in, housewares? Is it in furniture? Is it in, you know, clothing? What kind of department is it in? Maybe what are different tags that we can maybe use to find those things? So the reason I'm mentioning this is because when you log into a database, you have to understand what data is stored in that database. And on a server, which is essentially just a computer, you can have many databases, and each database can have many tables. So a table looks essentially like an Excel workbook. You've got rows, you've got columns, and it is really important when you're dealing with SQL to understand rows versus columns, because in SQL, certain features specifically target columns or they target rows. And so a column is a kind of data. So we've got, let's say, the user's name, the user's email. And then we also a lot of times have a unique key called a primary key. And that is just a unique identifier. So it might be called an ID, it might be called a key, depending on the name. And so user number one will always be user number one. And when we see orders for that person, it'll always be based on, let's say, or user number one, because their name, there might be multiple people that have the same name. And in theory, you might think, well, email is unique. Maybe, only one person would have that email, but technically the email could shift from one person to another. Like, let's say you give up your email at gmail.com and somebody else takes it. So that email might not be yours forever. But if we behind the scenes give people a unique ID, then we always know that that person, whatever their name is, whatever their email is, will always be user number one, even though they don't see it. So whatever that information is, though, each column is a kind of information. And then a row is a particular grouping of things, like a particular user. What is their user ID? What is that user's name? What is that user's email? So rows being a grouping of various different types of data, and columns being one kind of data. Very important thing to keep in mind when we're doing SQL, because certain SQL features focus on columns, certain ones think about rows. And when you think about this compared to an Excel file, the database is like a whole entire Excel file that's a multi-worksheet Excel file. Now, that's a very simple comparison. It's not an actual file. I can't take a database as a file and just copy it from one computer to another computer. It is stored in a more unique kind of way. I very much wish I could just take one file and say, oh, let me move this database from one computer to another. It doesn't work that way. SQL doesn't work that way. It doesn't store things as files. It stores things in a certain kind of compressed, optimized way, but just in general idea. Think about a database sitting on a computer on a server as like an entire Excel file. And just like Excel files can have different worksheets, each table in the database would be like a different worksheet or a different tab at the bottom of your Excel file. And each one of those tables would have a unique name and have a unique purpose for existing. Columns are the same in both Excel and in our databases, and rows are equivalent in both as well, as long as we're building kind of proper data structures in Excel. Now, when we talk about Excel, there are different what I call flavors of SQL. So it is not just one language, even though they would call it structured query language. It is just like English has different flavors of English. Like you go down in the South and people say, hey, y'all, right? And let's say in New York City or Washington, Washington, D.C., we normally don't say things like, hey, y'all, right? And so different places you go will have different local things that they'll say, different accents. So that's kind of like English has different flavors of English. Fundamentally the same thing. We basically say the same thing, but maybe slightly different versions of it. So if you learn SQL on one particular flavor, you can go to another flavor of SQL and you pretty much know how most of it will work. So each database is created by a certain company or organization, and there is this database management system which basically is what kind of database is it running on the server? And each group or company that makes the kind of database decides how do they want to extend or change something about the SQL language. So it is kind of, there's no standard version of SQL. There is just the concept of SQL, and everybody does a slightly different version of it. So, for example, Postgres is an open source group that creates Postgres. Technically, it's Postgres SQL, but we normally just say Postgres for short. But Microsoft, for example, they have their flavor of SQL. So they have Microsoft SQL Server. Often we just call it SQL Server, which is not to be confused with the server itself. It's just that's what Microsoft calls their flavor of SQL. They call it Microsoft SQL Server. There's also MySQL or MySQL or Oracle. There's lots of different ones that are out there. These are just some names that maybe you've heard of. Today we'll be talking and looking at Postgres in particular. But for the most part, the things that I'll be showing today should work in any flavor of SQL. Most of the language works the same way in all the different implementations, but sometimes you'll get into certain features which work a little differently here or there. You know, like in the UK, for example, they spell color with a U, but in the US, we don't. We don't put a U in the word color. Fundamentally the same thing, just slightly different things. That's kind of the idea of what I'm talking about here. So, once you know English, you can get by pretty much anywhere. Once you know SQL, you can always look up, hey, if I know Postgres, what's the equivalent in SQL Server if there's something different, if it doesn't work? I always just try it to see if it works. And if it doesn't work, then I will look up what's different about that in that other flavor. I point this out because whenever you're connecting to a database, you are connecting to a kind of database. Is it a Postgres database, a Microsoft SQL Server database, an Oracle database? And depending on what server you're connecting to, then that will determine the flavor of SQL you're using because whoever makes the database determines how you can speak to that database. And if you're ever going to be asking a question either in AI or if you're Googling something, don't just say SQL. Say what flavor of SQL you're using because there can sometimes be differences between them. So, why do people still use SQL? Why is it so popular? Think about all of the data that we're dealing with. All these companies, these websites, these organizations, we can't hold all of our data in just our local machine, just on like an individual computer. We need a place to store all of this. If you have terabytes and terabytes of data that we want to analyze based on all of, let's say, customer information or statistics, there might be so many statistics that you want to collect over years and years and years, and you want to analyze all of that data. We can't just store that in an Excel file or just a CSV file. I mean, we could, in some cases, Excel files are limited. They have an upper limit where we hit the limit and Excel files can't get bigger. CSV files are just text files, so they can get bigger, but it's just not efficient. So if you ever try to work in Excel with massive amounts of data, you probably realize that it gets sluggish and it's just not easy to work with massive amounts of data because Excel wasn't built for millions and millions and millions of lines of data. So that's where something like a SQL database is going to be much more powerful. It's going to be able to process that data much more efficiently because that's what databases were built for, was storing and going through massive amounts of data. SQL focuses on just one thing. It does not do a lot of different things. It just works with databases and the data that's stored in them. And so because it's just done one thing, that's what it's focused on. It was created a long time ago, and it really hasn't changed very much because we're just basically putting data in and getting data out. And so they kind of figured out how to do that. That really hasn't changed a whole lot. And so if you think about it, what technology today are you using that was created in like the 1970s? Like that was over 50 years ago, right? And so what technology today are using? Not many technologies were created 50 years ago. And so why do we care about that? Well, the good thing is that This is a very stable platform of something that really isn't going to go away. It's been used for a long time. It's going to be used for a long time. And it's not something that you have to be learning on a daily basis or a weekly basis, like changing things, new trends. Like once you learn SQL, you know SQL, right? So there's less to learn about SQL than other kind of languages. So JavaScript and Python and these other languages, there's a lot of different libraries and things that we can use. They're changing. People keep coming out with new features. They do so many more things. I call them the Swiss Army knives of languages. They do lots of things, which is very versatile. But that also means there's lots of things to learn and new features coming out. Whereas SQL, it's been around for a long time. It does one targeted thing, which means once you learn it, once you become good with it, it's not something you have to just keep learning over and over again and learning and keeping up with the latest trends. It also means that you can learn it and get good with it faster than most other languages. So, and it's just because it doesn't do as much stuff. So there's not as many things to learn. Now, you can get deep with certain things, but you can quickly get up to speed with SQL by learning a few different features, and you can do quite a bit with just those few basic features. So that's good. I think that if you're going to learn any sort of language out there in terms of getting into data analysis, data science, SQL is one of the fastest things that you can kind of get up to speed and become proficient in faster than a lot of other things. Like Python, they say it's a great first language to get started with. It's a lot bigger. It's a lot more complex. It's a great language to do a lot of things, but it's the Swiss Army knife. It can do so many different things. SQL's very focused. And it's one of the most widely used skills when working with data. Stack Overflow, famous website, they did a developer survey where developers, like serious developers, go on a Stack Overflow and they fill out this survey. And in 2025, so just last year, it was used by 58.6 of developers. So if you look at the percentages here of the top most popular technologies, JavaScript, HTML, and CSS, these are web technologies. SQL, here, there's more SQL developers than even Python developers. Now they're very close, but if you look at those, so Python is used by almost the same amount, but those are more data scientists, data analysts, people doing data type stuff with these languages. So more than half the people using this. And so these are the kind of the most popular ones out there. So SQL has been around for a long time. It's still widely used, right? And so just to point out that SQL is worth learning. And this was a great advice here. Somebody messaged on X. They said, "Do you have any recommendations for which of the 1,000 tools to learn for an entry level data analyst?" And Seth Rosen replied, "Five things you should learn: SQL, 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 SQL." Basically, like learn SQL uh, to get into data analysis. Uh, so it's a great skill. And even this year, they looked at the top skills in 2026. They still are saying that most data analyst jobs require SQL. Still super important. But things like, of course, SQL, Excel, Python, Power BI, Tableau. Also notice how Power BI has really come on strong and kind of overtaken Tableau as far as market share as well. Power BI and Tableau being very similar programs to each other. So SQL still on the top of that stack there. So how are we using SQL across our various industries? Well, it is used in lots of different industries. It's used on websites. For example, WordPress drives 40% or more of all websites, which is a really huge amount. If you consider the entire internet, 40% or more of all websites use WordPress. And behind the scenes, WordPress uses SQL, uses a flavor called MySQL. And that's how they store all the information about the websites. So 40% of the internet uses SQL. That's not going to change anytime soon. So it's used on websites. It's also used when we work with our business data or organization data. So SQL, it stores, it retrieves, and it manages all of that business data or organizational data that we rely on. There's a quote here. A lot of software is built using SQL. So pretty much everywhere you go, every software you use, anything online, all these tech companies, they require some sort of SQL knowledge because the software is built on the back end of SQL. You might not see it, but that is what it's built on top of. That's the foundation. So huge companies like Amazon, they've established that we use SQL. They use it in the cloud for storing information. The cloud is just another term for the internet, right? So cloud, various services, they're all built on the back of SQL. That's not going to change because pretty much the way we store and retrieve information online through SQL databases really doesn't need to change. So it's been around, it's going to be around for a long time. And I emphasize that because I know that we live in a very evolving world in terms of things like AI getting involved and so forth, but SQL's been around. It's going to continue to be around. And even though, excuse me, even though AI might help us to write our SQL queries, we're still going to be using SQL as the foundational knowledge, or the foundational tool that we use to bring out that information, to gain knowledge from our data. Because the goal of using SQL is to retrieve information from our data, right? To get insights. They call it Power BI. That's business insights, right? So the whole idea here is trying to get insight into your data. If your data is stored somewhere and you're not looking at it, you don't know what's going on, right? So in that database, you can store every data about whatever your organization or your business is doing. So whether it's statistics of things that have been happening, client information, contact details, whatever the information is, it's all in there. But if we aren't kind of pulling it together and looking for trends or totals or looking for things, we don't know what's going on. So, for example, I could search all that data and I could look for every client that spent at least a certain amount of money with my business over the past, let's say, decade or past amount of months or years. So because maybe I want to reach out to them and see like, oh, hey, you've been spending a lot of money with us. Is there anything that we're not providing that we could do better on? Right? Those are our valuable customers. The same thing could be true of statistics where you're pulling a lot of information, you're storing it there. But if you don't go in and try to pull out insights to know, well, what are the things that are happening the most frequently? How many times has this event happened, or how many times has this event happened? Let's sort that by the most prevalent events and pull those things up. That data is just sitting there if we're not doing anything with it. So we need to extract it, do something meaningful with it, and not just look at the information as a whole, but try to filter it down and get to what the interesting parts of that is. And when you compare something like SQL to Power BI or Tableau, Power BI and Tableau are just two apps that do similar things made by two different companies. So Microsoft makes Power BI, and Tableau was an independent company that was bought by Salesforce. So these are two apps that do very similar things made by two different companies. SQL is where we extract and deal with data. So essentially, we're trying to get answers to our questions from the data, right? So we kind of ask a question and we use a SQL query to retrieve that data to answer that question. Power BI and Tableau do the same kind of thing. They are visualization softwares. And while they can do very similar things to SQL in terms of extracting information, showing us that stuff, the main focus there is turning it into data visualizations. So how can we visualize it? How can we create things like pie charts and bar charts? And you can display things as tables if you want to, and summarize things and average things and do those sort of things. So you can do sometimes similar things to SQL in kind of a little bit less of a coding kind of way. But they are ways that we can visualize and build reports that we can then share with other people. So it could be a nice way to distribute that information, getting maybe information from, let's say, a SQL database. So these things are complementary. They work together well. So for example, we might want to connect Power BI or Tableau to be able to visualize some data. We might want to connect them to our database. And so we could allow them to connect and get access to all the data, but we might not want them to. Maybe there's some private data that we don't want them to be able to access. So in SQL, we can do some SQL code. We can create what's called a view. And that view would be able to be something that people can connect to. So instead of connecting directly to the whole database, they could connect to a view, and then we can limit what they can view. We limit what they can see. And that way we can limit what they pull into their reports. So that way it helps us to secure our data. So this is a way that Power BI or Tableau can work with SQL. This is where knowing SQL can help us to work with those. So they can do different things. They can also work together at different parts of the workflow, like write a view first in SQL, and then Power BI or Tableau can connect to that. Also, if you understand SQL concepts, so if you understand tables and rows and columns, joining and filtering data, these fundamental base concepts of how data works actually helps you to understand and better use Power BI or Tableau if you're interested in getting into those, if you're not familiar with those. It's a great quote here. If data is the true currency of modern business, then data jobs must surely be amongst the most high profile and high paying roles in tech. The idea being that these are valuable skills for people to have, that if you know how to go in and retrieve information, you know, and make sense of it and do something with it, that's a very useful skill to have. Because if your data is just sitting there and not telling you, it wants to speak, but we have to ask the questions. We have to be able to go in and retrieve that. And people have the questions, and we're going to use SQL to answer those questions. So I know I've been talking a bit here, and I want to do some live demonstration. So how do we connect to a database? How do we start writing our SQL queries? Well, the first thing you're going to need to do is be able to connect to a database. And just like we go into a web browser and go to a website, we need that web browser to be able to browse websites. Well, we need a database browsing application, essentially. So we need some app to connect to the database and to run our SQL queries. There's lots of different apps that are out there. One that I like is dbeaver, as in database, right? DB. There's a community edition, which is a free version. There is a paid version. There's dbeaver.io, which is the community free open source version of this. That's different than dbeaver.com. Dbeaver.com is the commercial paid version of this. The community edition is fine, the free open source version of this. Now, all of these database applications are very similar in concept. So if you cannot get dbeaver, that's fine. I just mention it because it works on Mac, it works on PC, it works to connect into pretty much any kind of database. It is a generic database program that can connect into virtually any kind of database. There are other similar applications like for Microsoft, they make their own Microsoft SQL Server Management Studio, which is their kind of equivalent of dbeaver. But the SQL Server Management Studio only connects into SQL Server databases. That's it. Whereas dbeaver can connect into SQL Server databases, Postgres databases, pretty much any kind of database that's out there. So if you can't get this particular app, that's okay. Whatever database app you're using, or sometimes there are cloud-based versions where you log into a website and you're basically doing the same kind of equivalence in a website, but you need something to connect into the database. And later I'm going to show that if, let's say, you just want to practice something and you want to try this out yourself, there's a website that I'll show that's called mode.com. And if you don't have your own database where you can go in and experiment and you want to play with things and try to write your own queries and start to learn Postgres on your own, I'll show you that you can create a free account with mode.com. And they have a public data set that you can play with and you can query and extract information from. It's been very challenging as a teacher to get people to connect into a data set because most databases they're private, right? Like organizations, whether it be government, private organizations, businesses, we don't normally expose our data to the general public in most situations. Now, there sometimes can be public databases in certain cases, but in most cases, most of that stuff is privately held because we don't want the general public to be able to go in there and see that in a lot of situations. So it's kind of difficult to find public data sources, and mode.com was the only one that I could really find that had a public data set. I'm going to, just for the sake of this demonstration, I'm going to be using dbeaver and connecting to my own database, which I use for training, but that would not be one that you could publicly access, whereas mode.com you will. So let me show you how all this works. I'll start by connecting into one of my own databases, and then I'll show you how mode.com works. And so I'm going to switch over to dbeaver here. So I've got my dbeaver installed on my computer. This is that free community edition version of the application. And let me just pull up my notes here. All right. So here in this now, whether it's dbeaver or some other application, we need to create a connection to our database. Basically, it needs to know where is that database living. It's somewhere on the internet. Kind of like when you go into a web browser, you type in Amazon.com or Google.com, and you can get to a website. Well, same thing needs to be done for our database. So in dbeaver, I can go in and I can create a new database connection. This is where I put in all the information for how it's going to connect to my database. And this is going to save it as a stored connection over here once I'm all done. Now in dbeaver, I can connect into all of these various different types of databases, tons of databases. The popular ones being things like Postgres or MySQL, Microsoft SQL Server, those kind of things. But I'm connecting into a Postgres database. Why is it Postgres? Because the server that I have my database on is a Postgres server. So I have to choose not the flavor that I want to use, but the flavor of whoever created the database. What did they use to create their database? And so the person who created this database used Postgres. So they set up a Postgres server for this. And it wants to know what is the host name. So this could be a internet address, or it could be, in my case, it's an IP address, which is a number version. Instead of Amazon.com, there's always a numerical version of that. So whether it's a name or a number, this is like your internet address. And so I'm going to copy that from my notes here. And so this is like your internet address. This is a unique place on the internet of how it can go into this particular computer, whether it's a name or an IP address. The database is going to be the particular database that you're connecting into. Now, by the way, this information, whoever created the database, they'll know this information. So if you were ever going to connect into a database, the person that created it, they'll have to give you, let's say, a username and a password to access the database. We don't just let anybody access this. It's kind of like when you go to Amazon.com, you can create your own account there. But normally on a database, someone who is an administrator has to create that username and password for you. So they're going to tell you what the host name is. They're going to tell you what they name the database. So I can't tell you what your host name will be. I cannot tell you what your database name will be. But the person that created it, the person at your organization or your company, they will know that and they will tell you. So in my case, I've got a company underscore data is the name of my database. That because you can connect into multiple databases as well here. In fact, I could say, well, just show me all the databases, not just this one, but there could be other ones as well. It's going to primarily connect into this one, but I can see the other ones as well. And then I need a username and a password. So I'm going to put in a username here. Now, this username would be given to you by whoever is your database administrator. So you would need to find out from your database administrator, what is the basically address, what database am I connecting into, and what's my username and password. And I'm going to test this connection to make sure I didn't make any typos. And it did successfully connect. It's kind of like I'm going out to Amazon.com and logging into my account, but it's the database equivalent of this. At any point in this process, if you're using dbeaver, if it ever says, do you want to download driver files? Then you would need to download those. You just say, yes, go ahead and download those driver files. You don't have to download them very often. Maybe the first time you're connecting into a Postgres database or the first time you're connecting into such and such a database, you would have to download those, and only if there's future updates. So you don't have to download those driver files very often. And when I hit finish here, that creates a new connection over here. And this new connection it's kind of like a bookmark. It just remembers what is the IP address or address, what's your username and password. So it now remembers that this is that training database. Now, I don't like that it named my bookmark, essentially, my connection over here. I don't like that it named it the same as my database. So I'm going to right click on this and I'm just going to rename it. And I can call this my training database. Actually, I'm going to call it my training server. My training database server. Because that's the server. This is the connection to that server. And when I open it up, it's going to connect to that server. And it's going to show me all of the databases that live on that server. So this is just a bookmarking of that server. So I never need to enter that information again. It remembers that because I saved that connection. If I ever right click on this and I delete this connection, it's just like deleting a bookmark in your web browser. It forgets that information. Or if I made a typo and I need to edit that connection, I can go back to edit that connection. And I get back into the same dialog where I can edit any of that information should I need to make a change. But assuming that none of that changes, that is just a connection that anytime I open up dbeaver, that's now going to be saved. And I can go in to my databases. I can go into my particular individual database right here. And in schemas is a collection of tables. It's like a grouping of tables. I only have one grouping of tables called public. It's possible you might have more groupings of tables. This is if you have a lot of tables in your database. But I just have one schema, which by default is called public. We could have additional schemas or grouping of tables if we chose to. If we had a lot of tables, we might create multiple schemas. But here are finally my tables that I can see. And if I actually double click on tables, I can see a diagram of how these are connected. So I double clicked on tables, and I'm going to zoom in on this a little bit so you can see this better. And here I can see that I have my users table. I have my orders table. See how there's a connection. So users can place orders for various line items and the products that go with those line items. So here I can start to understand the relationships of tables. For example, I can see that employees work in certain departments. And then I see other things that are different that are not connected into the main data that I have, things like views that I mentioned earlier. So these are the main data parts that I'm going to be working with. Now I can close that tab. Also, if I want to see any particular database table, so this is the database kind of server. This is the individual database, and these are the individual tables sitting inside of that database. So if I, for example, double click on users, I can see various settings about the users table, but I can see the data, and it gives me a preview to show me what this looks like. So I can actually see some of that information. All right, so I'm going to close that up. Now I actually want to write a query so I can query or retrieve some of that information that's over here. And for that, I need basically a coding file. And so we're going to edit some SQL. I'm going to create a new SQL script here. Basically just creates a new file. Not to be confused with file and saying new. That's different. No, I'm going here to new SQL script. And when I create this SQL script, this creates basically a blank text file where I can type out some SQL code. Now, before I do this, I just want to make sure up here that I'm actually connected to the correct server and that I'm connected to the right database sitting inside of that server. Because technically, I can have multiple connections over here. So here, for example, there's another database that I'm connected into. So up here, if I click on this, I can actually choose which database do I want to connect into. Because I might be working for different departments, different companies, and connecting into different databases. Generally speaking, when you create a file, the one that you're looking at, whatever is kind of opened, whatever you're selecting, generally, when you create your new SQL script, that should be the one that it defaults to. But it's always a good idea to look up here just to make sure that you're connected to the correct server. And once you're in the correct server, so that's my training database, over here on the right, if I click on that, I can see that this is the database that I'm connected into. And then this is the schema or grouping of tables. So I could say, oh, I want to switch into this game shows database over here. And then I could connect into this schema, double click on that. And I could see now I'm going to be querying not the company data, but I'm going to be querying the game shows, which only has one table, which is the Jeopardy. So here I'd be querying the game shows database, this table over here. But I want to be using the company data. So I need to make sure I'm in company data. My point is, whatever you're looking at here is just what you're exploring. And what's up here, there's always going to be a place where you can choose what is your query actually going to be running against. Where are you actually pulling that data from? Not just what you look at over here, but what you are setting up here. So from my training database server, from the company data database, I can now talk to any of these tables that are here. And I can write my SQL. So I'm going to say, I want to select everything. Asterisk is shorthand for everything. And I can do from any of these particular tables. So let's say from my users table here. Notice how it does automatically code hint, which I can then choose by hitting enter. And it's a best practice, although it's not required. It's a best practice to end your queries in a semicolon. And now I can run this. So this is going to select all of the columns from the users table. And when I run this here, when I execute, I'm going to hit the little play button over here. It's going to run that query. And I'm going to see all the columns. That's what asterisk means, all the columns from that users table. I can also go into that users table and I can see the columns that are over here. And then I can see that it has returned all the columns and all of the rows as well. But select asterisk means give me all the columns from users. Now, what if I didn't want all of those columns? Maybe I don't need all of that. Maybe I only want people's names and emails. I'm going to keep this query here, and I'm going to hit enter or return, and I'm going to write another query here, and I'm going to do the same query here. But instead of the asterisk, which means all, I want to type in, let's say, name and email instead. So I can change this, and I can say name and email. And I can put a comma in between those. And because I put name first, it'll put the name as the first column and email as the second column. And I only want to run this query, not this query. So dbeaver is very smart in the sense that when you click your cursor into a query and then you hit this execute button, it only executes the query that you've clicked inside of. If I click into this query and I run this, it'll only execute that query. So instead of running all of this code, which would only happen if I select all of it and then I run it, and that would give me two different results down here because each query returns a set of results. Normally what you're doing in SQL is you're just clicking into one query and then running that one query. You might keep additional queries because you want to run different things, but you don't want to run them all at the same time. You probably just want to run one at a time. So just click anywhere into a query and hit run. Now, depending on the app that you're in, that might not work. dbeaver is very smart in the sense that when I click into a query and then I run it, it only runs the current query, the one that I've clicked into. If your database application does not do that, you might have to select the query. And then only what's selected will be run when you run the query. That's how some other database apps work. Now, you do have to be careful. If, for example, I select the user table, not users, because it is called users, this will fail because it actually only runs what you've selected. So you have to be careful of that. If you don't select the entire query, it'll only run what you've selected. So either make sure you selected it all and then run that query, or if you're in dbeaver, just click anywhere into the query and run it, and it'll run that query. Notice how this is selecting the name column and the email column, whereas this one was selecting them all. You can order these in any order you want. So if I want to put email and then name, we can put them in any order we want. So you can choose what you want to get. And the idea is that while it is fine to get started with a select all from users just to kind of start to get a sense of what's there, you're going to want to filter this. So for example, in my products table, I've got a products table here. And in here, I've got various products. I can say, let me select everything from the products table. And these are all my products. All my titles, my prices, my tags. Most of the time, you're not going to want to find everything. So if I want to only find tags, so products that have a tag of cyan, I can say, I only want to find products where the tags column, so I type in the name of my column there, tags, equals, and I want cyan. Now, cyan is text. So if you have something that is text, you need to put single quotes around text. And notice how this says A to Z as opposed to 1, 2, 3. So some things are numbers. Numbers don't get quotes. But things that are A to Z, things that are text, they get single quotes, not double quotes. That means something different. Single quotes here. So I want to select all the columns from the products table, but only show me rows where the tags column contains cyan. So notice I don't get all the rows. Select chooses the columns From gives me the table, and where decides which rows. Only show me rows where tags equals cyan. So I'm no longer getting all of the rows. SQL is all about a filter. What are we filtering down? You don't want to see it all. You only want to see some things. And by the way, if you select an area of a query and run that, notice how we're seeing everything from products. But because I didn't select where, it didn't give me that part. If you select the whole thing, then it will run the entire thing. You can also put your queries on different lines. And if you click anywhere in the query with the semicolon being the end of that query, it'll run all of the lines of that query unless you select only one line. This will be the unfiltered table. Whereas if you run it with where, that will filter it so that you only see some of the rows, not all the rows. Let's do another example here. If I go into my products table here, that will be all the products. But I only want to see products where there's a price that is greater than 80. Now, 80 is a number, so I don't have to put quotes around it. I only put quotes around text. So it looks in that price column and only shows me rows where the price is greater than 80. Now, I might want to sort these. So I could also then say order by that price column. And order by will say, let's sort by, order them by price. Notice how it goes from small to big. If you want to flip that, because the default is in ascending order, so it goes 1, 2, 3, 4. It's ascending by default. We could say, no, let's do descending order, meaning let's flip it. So it descends. It goes from 10, 9, 8, 7, so forth. So it goes down. So you get the biggest amounts at the top. You have to write your queries in a certain structure. Remember, I call this a structured query language. Select must go first, then from, then where, then order by. There is a specific structure. So for example, the structure is select, from, join, where, group by, having, order by, limit. These things, if you're going to include them, which you don't have to include them all, if you're going to include them, they must be put into that order. They cannot just be put into any order that you want. They've got to be put into a specific structure, meaning you can't put the order by before the where. You can try, but it won't work. So if you put that there, this query will fail because we didn't put it in the correct structure. You must put things into the correct order, and then this query will work just fine. All right. Now, you might want to do some sort of analysis of things. So for example, if I look in my line items table, so I've got a line items table over here that has some columns. If I want to look in there and I can see how much these things cost, I could say, well, I want to, let's say, I want to know how many things were purchased. So let's say I want to do the quantity here. These are all the quantities. I just said, let me just show that quantity column. So just select the quantity column. But I want to add everything. Like, you know how you do a sum in Excel? You can say, I want to sum all the quantities. So that does a sum of everything in that column. Nice. Now I could also, if I have price and quantity, I could say, well, okay, so if I've got, that's the total quantity sold. But what if I want to know how much revenue? That's quantity times price. So I could say quantity times price because I've got price and I've got quantity. That would give me the revenue. Okay. So you could do things like this and you can group things, for example. So let me keep this and create one more down here. And let's say I show you all of these columns again. Notice how I've got status over here. I've got a few different statuses. I could group by the status. Now, if I'm grouping by the status, I need to show people those statuses. So they're going to show that status column. Grouping by means to say, let's take all the shipped and let's put them together. So these are the statuses that I have. But just seeing the statuses themselves, just seeing the groups is not really what I want to do. I want to put it with some sort of analysis. Like I want to know what was the quantity sold per status. So these are how many things were returned, how many things were shipped, how many things are pending, how many things were canceled. And if I want to know the revenue per status, I could put in the quantity times price, and then I know my revenue for all of those. So the point is that you can do analysis where you can take all of that vast amount of data and then you can start to put it into groups. You can start to do calculations with it to make sense of all of that vast data. So this is how you connect into a database. You start to run your various queries and start to use this structured query language to start to understand what's going on in your data. Now, if you don't have a database that you can connect into right now, and maybe you can't install this application if you want to try something out just to kind of quickly get started to experiment with this, mode.com is a free website that, well, I mean, they have some paid features, of course, but you can sign up for a free account. And when you go to mode.com and you sign in or sign up for a free account, which I already have a free account, this could be a way if you just want to get started and try something out where you don't even have a database. I can go into my work over here and I can use their data set that they have for free. Where I can go into my work, I can use the data set. I'm not going to use one of these. I'm just going to cancel this. I know it's a little unintuitive here to cancel, but I just want to write a SQL query. And over here, they have a tutorial public warehouse. So this is their database, which this is where most people don't publicly offer databases. But with any of these, I can say, hey, let me make this bigger here so everybody can see this. Select everything from, and then let's say I want to look at the accounts. So I could double click on accounts, and that types in the name of the database tutorial dot accounts. So database dot table in this case. And then when I run that, it can then show me that. Do I need to type in the name of the database in this case? Yes, I do. In this particular case, that's just because they must have multiple databases that it might be able to connect into. So I do have to type in the name of the database and the name of the table. And so they have lots of information that you can start to query from. If you want to show certain columns, like I did, like the name and the primary contact, primary. And one thing I don't like is that they don't do code hinting, but if you select your table over here and then you see the columns, you can just click where you want it. And then if you double click, it'll type in the name of your database, your table, your column there. So it could just pull these two columns from that particular table. And then we can see, we could just pull those two columns there. So you can do filtering with where and all that sort of stuff. Like I just want to see where the name equals, and then I can say Walmart because I see that somebody's from Walmart there. And I can find the person who's the contact at Walmart. So this is one way that if you want to try to get started with, if you don't have your own database to try to do this yourself, if you can sign up for a free account at mo.com, you can use their database and just start experimenting and trying to write your own queries. If you want to learn more and take some courses with us, we'd invite you to go to graduateschool.edu/topics/SQL-classes. And if anybody has any questions, I'm going to throw this link also, by the way, in the main chat just to make this easier for you to click on. But you can check out our various classes there. If anybody has any questions, feel free to ask them in the Q&A. But otherwise, if you don't have any questions, that's going to be a wrap for today. I hope you've learned some useful things. But if you do have questions, feel free to ask those questions in the Q&A panel. There should be in the Zoom controls. You should see Q&A that you can click on. I hope this has been beneficial and useful for all of you.